All right, this is Unit 17, Lesson 2, called Reflections in a Plane. What we're talking about here is, as we talked about yesterday about transformation or translations, we're going to talk today about reflections. Okay, a reflection is a transformation of an object or a geometric figure in which each point of the object is transferred across a central line so as to have the same distance to the line. The reflected object is congruent to its original self. An example of that is what this is showing you right here. Okay, so that's what this is. Okay, so this is a reflection across the central line that is called the mirror line in this diagram. Okay, the central line can be called by any of these names. Okay, the first one is mirror line, or it can be called the axis of symmetry, or so either one of those will work. Okay, the process of producing such a mirror image can be called any of these. Okay, mirroring, flipping, reflecting. Okay, this one is the official terminology. So when you see this, you should refer to it as a reflection. Okay, such a transformation of an object so that it is congruent to its original self is called a rigid motion, which is what we talked about yesterday. Once again, this is called an isometry. Okay, examples 1 and 2, we have this. In example 1, we have reflect a point A across the y-axis to produce A prime so that its distance from the y-axis is the same. Okay, so here's our original point. So if it's going to be the same distance away, it has to be 2 units on the other side of y. Okay, so since they've got these as 2 boxes per unit, so that's going to make it come out to this. Whenever you do it, it would be positive 4, 2. Okay, example 2. They want us to reflect point B across the x-axis to produce point B prime so that its distance from the x-axis is the same. So here's B. So once again, this is 2 units from the x-axis, so we need to go 2 units below the x-axis straight down. So B prime is going to be right here at 3, negative 2. Okay, example 3, they want you to make a sketch of the reflection of this object across the y-axis. So what you do is you establish what the 2 points are here that are showing to you at the beginning and end of the line segment, or actually the arc, and create the 2 points that are going to be across the y-axis from it and connect them with another arc. Okay, so that's how you do it. That's the reflection of this. Okay, example 4, they want to make a sketch of the reflection of this object across the x-axis. So once again, we find the 2 points and connect them with an arc. Notice it's the same thing we did before. Find the distance to the axis and then go that same distance to the other side and then connect them with the arc. Okay, draw the reflection of this object across the line y equals 2 and label the new object appropriately as A prime, B prime, C prime. Okay, so our original object looks like this. Y equals 2 is this dotted line going through here, so we have to find how far it is to that line. For C is 2 units, for A is 2 units, and for B is, looks like 5 units. So we want to go straight down 2 units on the other side for A and C, and straight down from the line 5 units for B. And that will give us this, which looks like it, and this is what is called A prime, B prime, C prime. Okay, example 6, they want the mirror image of this object across the line x equals 8 and label the new object appropriately as D prime, E prime, F prime, G prime. Okay, so here's our original quadrilateral, DEFG. So notice what we got here. The dotted line is where x is equal to 8. So we're going to count the distance to that line and make the mirror image of the points on the other side. Connect them with line segments, and this is what we get. We get D prime, E prime, F prime, G prime. Okay, the process is, when given the coordinates of a point, simply change the sign of the x value to produce a reflection across the y-axis. So when given the coordinates of a point, simply change the sign of the y value to produce a reflection across the x-axis. Okay, example 7. Several vertices of a polygon are given in the left table below. Fill in the corresponding coordinates in the right table so as to produce reflections of those points across the x-axis. Make a sketch of the points in both tables, connecting adjacent points with line segments. Okay, so here's our original polygon, and these are our points. Since we're going across the x-axis, that means we're going to change the sign of the y's. So the first one would become -5, -4, -2, -2, -1, 1, and 4, -1. And then when we connect those up, we get something that looks like this. Okay, example 8. So once again, they give us several vertices of a polygon. They're wanting us to do exactly the same thing, except this time they want us to reflect across the y-axis. So this means we change the sign of the x's. So -5, 4 will become +5, 4. So we have +5, 4, +2, 2, +1, -1, and +4, 1. When we do that, this is what we get. Okay, those are two of the common things that they have you do. Another common thing that they like for you to do is this. They like you to reflect things across the y equals x, which is a positive slope, 45-degree line that's passing through the origin. So to do this, we just change the order. So what was x and y to begin with become y and x on the other side. So you just flip the coordinates, and that will give it to you. So here we are again. They're giving us the same idea that we were doing in example 7 and 8, except this time they want us to do it across the line y equals x. So -5, +4 will become 4, -5. Then it will become 2, -2, and -1, -1 will stay the same. And then 1, 4 will be the last one. So this is what you end up with. Okay, once again, the dotted line is the line of reflection, which in this case is the equation y equals x. Okay, that concludes the lesson 2. So once again, if you got any questions, make sure you write them down while you're thinking about them. Bring them to class tomorrow, and we'll be glad to discuss them before we start any work. Thank you very much. Goodbye.